Hey everyone, it's Justin again. In this lesson, we're going to be learning the final method for solving a system of equations called elimination. In this video, we're going to be reviewing a previous skill that'll be important in order to use this method successfully. What is 5a plus 2a? If you said 7a, then you're right. Okay, that was too easy. How about 12b plus negative 11b? It's 1b, or just b. Okay, I feel like we need to crank up the difficulty a bit. How about 4l plus 9f minus 4v plus 3l minus 9f plus 7v? The answer is 7l plus 3v. But what happened to the f? Well, because we added a positive and negative version of the same term, they zeroed out. We could also say that the f term was eliminated. And as you can imagine, this is where the elimination method for solving systems gets its name. You might be wondering, how does this help us solve systems of equations? I'll show you. Here, we have a system. We could use graphing or substitution to solve it, but look how the two equations are set up. The x's, y's, equal signs, and constant values are all in the same location, practically lined up and ready to be combined vertically. So let's do just that. 2x plus negative 3x is negative 1x. And negative y plus y zeroes out, or is eliminated. And finally, 5 plus 10 is 15. By adding these two equations together, we've created a single equation with a single variable. This equation is incredibly easy to solve. Just divide by negative 1, and we find that x equals negative 15. Now we can do the same thing we did with substitution. Plug in negative 15 for x in either of the original equations, and solve for y. And just like that, we've got values for both x and y, creating a solution to the system of equations. Don't forget to check your answer. If we plug in negative 15 for x and negative 35 for y in the first equation, and then simplify, we see that it works. We can check the second equation in the same way. And that also works. Since the point negative 15, negative 35 works for both equations, it's a solution to the system. Here's another example. We can see that even though the equations aren't in standard form like in the last example, all the pieces are still lined up perfectly to be added together. Y plus 2y is 3y. 4x and negative 4x eliminate, and negative 1 plus negative 8 makes negative 9. Now that the x term has been eliminated, we can solve for y to find that y is negative 3. And we can now take that y value and plug it into either of the original equations. If we solve for x, we learn that x equals 5/4. Now that we've got all the information we need for a solution to the system. To check that solution, we plug it into the first equation, and it works. Then we plug it into the second equation, and it works there too. So then our solution is correct. All right, I think we got it figured out now. We add the two equations together, which gives us this, and nothing eliminated. Well, that's just because none of the terms happen to zero out. Just like this example, systems usually won't automatically be set up for elimination, which is why in the next video, we're going to be learning how to manipulate and prepare systems such as that one for elimination. See you then.